Thank you. So, my name's Karsten. I'm the president of Zyxel Communications. I'm quite excited to be here, but also a little bit nervous because I lost my voice completely during the weekend, and I hope it will last for at least long enough for this session. A few words about myself. I joined Zyxel roughly 25 years ago. I've tried to slip away a few times, but didn't really succeed. So here I am. As I said, I'm quite excited to talk about Zyxel's investment into prpl because this is becoming quite important to us and quite important to Zyxel's future. But before that, a few words. Prior to Zyxel, I was military for 16 years, originally as an engineer. And how a simple naval officer ended up running a hardware manufacturer out of Taiwan is probably a story that would take a few beers to explain, so I won't get into that here. Okay, I'm based out of Taiwan, as I said, but I still call Europe home. My family lives in Copenhagen, Denmark, I think. And at least this coming here brings me back to Europe and a chance to take up on that as well. So enough about me, right? I want to talk a little bit about Zyxel. Oh, there we go. Okay. Zyxel's been around since the late 80s, right? And what people don't know about Zyxel actually is that originally we started up as a chipset design house. Our founder, Dr. Shuni Chu, was the first one in Asia capable of designing a data pump in a chip. And unfortunately, those chips didn't sell so well. So instead, we decided to do our own modems based on our own design chips. And that's actually how Zyxel started. Those of you who was around during the narrowband era will know our legacy. We had some of the most renowned, some of the best modems and ISDN terminal adapters out there. And they looked absolutely horrible, but they were that good. Then 25 years ago, we moved into routers and became a networking manufacturer. And let's say for around the same time, we started focusing more or less primarily on the telecoms sector, making products for consumer subscribers. And we always kind of had our own software back then. We had our own Zynos, which was our Zyxel networking operating system, and it was designed for ISDN gateways. At the turn of let's say the millennium, when we entered the broadband era, we kind of started leaving Zynos a little bit behind, our own software behind, and more we started using the software development kits from the different chipsets and different platforms that we were using. And this required a lot of heavy lifting on our part because we wanted to bring a consistent set of features to the market, to our customers. But let's say the chipset vendors' architectures, they were like wildly different. So to achieve that, to actually bring the same experience on one chipset versus another was almost impossible, or at least required a lot of investment on our part. So maybe 10, 15 years ago, we decided this is just not working. And we started to lay the groundstone for what was our own in-house Linux broadband software stack called Opal. Now, the purpose of Opal was to be able to solve that problem. It offered the same features, functions, and remote management across different chipsets. And when we went to second generation of Opal, we started using OpenWRT because we wanted to be able to leverage some of the open source community, bring products faster to market. And OpenWRT did give us that. But even if it gave us a lot of benefits from the open source communities, there's still a lot of heavy lifting, both because the OpenWRT was never really designed for telecoms. It was more like a retail type thing, so we still had to put a lot of resource investment into that, and many shortfalls, and of course the support from some of the chipset vendors out there was lukewarm at best. But nevertheless, we achieved what we set out to do with Opal, even though there's a lot of investments going into this. And this kind of leads me to sort of the next point here. I mean, for those of you who know us, Zyxel is known as a hardware vendor. But the reality is I have twice the number of embedded software engineers than I do hardware. That's the reality. So I'm not even sure I should classify myself as a hardware vendor, right? We should more or less say we're a software house with ability to build products that the software can run on. That's probably a more accurate description. So a good product in our book is not only a question of being a cost-effective, high-performing, it needs feature-rich, and it needs robust software. Otherwise, it will fail in the marketplace. Right. So with that in mind, there's nothing happening here. Let's try. Okay, there we go. Let's look up, right? In the last decade, the world of telecom has changed a lot. I think most of you agree that the cloud is a thing, right? It's here to stay. So, so that also means a lot of things in terms of the subscribers. The subscribers networks today are purely wireless and complex, have multiple units, and an increasing number of IoT devices. So when we were looking at this and saying, okay, now we need to go to third generation of Opal 3, we need to look at this new reality, right? And we need to accommodate the system architecture that we're going to be using need to accommodate this new reality. So, and this is a reality where services are being deeply integrated from the cloud deep into the CP, where we have ESG requirement, we have AI in the cloud analyzing how to best optimize the power consumption in the device, and deeply integrated. We have a reality where services need to be able to move from the cloud into the CPE, and it needs to be able to move from the CP back into the cloud seamlessly. It's a reality where the cloud itself is not only a singular telecom ACS, it's multiple endpoints, AI engines, it's different owners in the cloud. So it's a lot more complex. And it's a reality where the subscribers network is no longer just a single broadband gateway. It's a whole ecosystem of active networking units, applications, cloud integrations, and IoT. So that's the reality that we were facing, let's say, for the next generation. So, with this, and with all these requirements in mind, when we were looking at the next generation, frankly, it was a bit of a no-brainer for us. Purple was the way to go, right? Although Purple, the dream of Purple being, let's say, a piece of turnkey software, we just install it on the device and then we truck roll it. That's not reality, right? It's not reality. There's still a lot of heavy lifting that we need to put into it, but the architecture fits the purpose like a glove, and that was the decision point. As the support for Purple becomes more widespread and mature and committed from the chipset vendors. Vendors such as us, Zyxel, and our colleagues out there, we can focus our attention and our resources much, much better than we do today. Of course, price, manufacturing cost, they're always going to be competitive parameters. But I think as a vendor in the future, we should be measured not only by that, but also be measured on the value that we are capable to put on top of Oppo. Oh, sorry, Oppo Purple. And that's exactly our focus with our next generation Oppo 3. So when we chose Purple as the basis for our future in-house software generation, it was not a fashion statement. It was simply the logical thing to do. Okay. And my closing statement here is going to be that we're here showing a bunch of AP. People tell me that it was that Purple Mesh could only do 4 APs, and I think the team, they made it into 8 or even beyond that. And we're bringing that kind of function back to the community as we should. Of course, we're not philanthropists, so if we have a new feature that we think you guys are willing to pay for, we're probably going to charge you, right? But we have a big team here. We're showing the demo. Come and challenge us on this decision that we have made. Tell us your opinion. We'd love to listen. Thank you.